Can you see it's the same? Can you see theta equals to S over R is the same as S equals to R theta? Okay, what does it mean S equals to R theta? Okay, when theta is in radians, today what I thought is the angle is in radians. Okay, this is the radius, this is S, that means the length of this arc is S. So, the length of S is actually R times theta, that's all. Okay, what does it mean? That means if I have this angle as maybe 0.5 radians, okay, and this radius is, let's say, 6 cm, what will be the length of this arc ACB? Arc ACB will be R theta, so it's 6 times what? 0.5, what do I get? 3. Just increase here. But you must make sure theta is in radians. Is that clear to everyone? So, actually, you can see when theta is in radians, right? How many radians? Hello? This is in radians, right? The radian measure is actually the length of arc. The ratio of the length of arc to the radius. That means how long is the arc is to the radius. Can you all see what I'm talking about here? Can you see it? Okay, so radian is the measure of the ratio of the length of arc to the radius. Okay, what does it mean? If let's say radius is 3, the length of arc is 6. So what will be my radius? 6 over 3, right? This will be how many radians? 2 long is the ratio. Understand? But I always use S equals to R theta. Is that clear? Okay, I'll give you another formula. Alright? Because I said I'm combining 8.3 and 8.4. Okay? Now, for these two formula, theta is in radians. Mass. Okay? First one, S equals to R theta. This one means length of arc. Okay? The second one, A is half R squared theta. This one is area of sector. That means you don't even need to try 16 whatsoever. If theta is in radians, the area of this sector is just half R squared theta. Understand? Half R squared theta. If theta is in radians. But if theta is in degrees, you cannot use this. Understand? Understand what I'm talking about? Okay? So these two formulas are only applicable when theta is in radians. Okay, I want all of you to turn the textbook to page 89. All of you turn to page 89. Can you see arc length S is equal to R theta? Page 89. Can you see arc length is R theta? Yes or no? Okay? Then can all of you also turn to page 91. Sector area is half R squared theta. Can you see it? Now, in both cases, they also tell you that the angle must be in radians. Otherwise, it doesn't work for these two particular formula. Is that clear to all? Yes or no? Okay, now, my aim today is to give you these two formula and then bring you through the examples of 8.3 and 8.4. Now, 8.3 will be very simple because we have already done the Amex part of it. Understand? So this one is no problem because in Emax we only do first two quadrant. We don't have third and fourth quadrant and no many now, only one now. Understand? Okay? Alright. So let's take a look at the examples now. Okay. Can we look at page 84? And all of you look at page 84. Hello? Page 84. Can you see on the top? Pi radian is 180. This one you know already, right? In AMS you already know, right? 180 is pi radians. Do you all agree? Yes? Okay, now, next. Example 6. Converting radians to degrees and vice versa. Okay, they want you to convert over 9 to degrees, and 3 over 8, 3.8 to degrees. Now, I will call you right, when you do direct proportion, that means you want to convert, right, like cm or whatever, you must line up, right? Now, can you see this is in radians? So you say pi corresponds to 180, am I right? Correct. You agree pi corresponds to 180. So you have to type pi online. So it's 180 over pi times pi over 9, right? Remember, I always say this over this times this, right? Okay, so this one will give me just how many degrees? 20 degrees, huh? Can you see or not? Can you see what I'm talking about? Can or cannot now? How come I do this? Remember this one I always say, if 4 apples cost $2, right? How to find 7 apples? 2 over 4 times 7, right? When you take 2 divided by 4, you find 1 apple. Then you times 7. It's the same. You take this divided by this times 6, you'll find out what it is. Everybody clear? Okay, exit properly. I don't want any accident during my lesson now. Okay? Alright, next particular example, 3.8. Okay. We will write pi corresponds to 180 degrees, right? What's the next step? Marshall? You got what? Huh? You got my pi? Times what? 3.8. All of you key for me now. All angles in degrees must be given to 1 decimal place. So what's the 1 decimal place? 217.7, right? Degrees. Is this correct? Is this correct? Yes or no? Okay. So next one, part B, they want to convert 167 degrees to radians. Now this one must write the other way already. Oh no. Because in O level, there was one that only asked you to convert at 1 mark already. So the 1 mark you must take percent. So this one I will have to write 180 correspond to pi. So how much to find this? Pi over 180 times 167. Okay, all of you find out for me now? Three significant figure. 2.91. So it's 2.91 radians. Everybody clear? Everybody clear with what I'm saying? Okay, now. Then I want to say something here. Second time, Lucas. Bring your whole thing, say that. Oh. It's not just today, it's for days. Okay. Now, I need to tell you, when your angles are in degrees, in order to look up, this is your presentation. You must write sine 60 degrees. If it's degrees, you must write degrees. Understand? Everybody clear? If someone writes sine 2.5, this one is in radians, no? It's understood that if you do not write degrees, it's in radians. That's why it's important. I will minus units mark if you don't write. Understand, ma? Can or cannot? Can, So degrees, you write. Radians, there's no need to write. Just write the number, can already. Everybody clear with what I'm saying? Okay, very good. Now, next. Okay, you are supposed to use the calculator to find the ratio. So everybody get ready your calculator. I'm walking down. Sometimes I have a calculator is in Jurong, that kind of thing. Okay, today is a very simple kind of exercise. Okay, everybody change your calculator to the radian mode first. Must change the calculator to the radian mode. Okay, key in the first one. Radian mode, key in the first one. three centimeter figure, right? So what is it? 0.985. Is this correct? What about the second one? Cosine. 0.551. How about the last one? 1.77. This is very easy, right? Correct. It will never come out. Outside, it will never come out. It's just tell you how to place on. Everybody clear? It's just to tell you how to change it to radian mode. Understand? Okay, now next. Example 8 is the one that I want to go through in detail. Find each of the following. For each of the following, find the value of x, where x is between 0 and pi over 2. Now, can you tell me 0 and pi over 2, which quadrant? First, right? Got second, right? So only got first, right? So it's only the A quadrant, am I right to say that? The means sine, cosine, and tangent are all what? Positive, right? Okay? Alright, good. So sine x is 0.77. X equals to what? You must be in your radian mode. Key in sine inverse 0.77. There's only one answer because I already got first quadrant, can see? Okay, so what's the answer? What's the answer? 0.871. 8. Round off. No, round off. 871. 9. That's the final answer. Okay. Next one. What about cosine x equals to 0.362? What is x? 1.20. Tangent x equals to 2.13. What is x? 1 point. Don't just look from a look from textbook. 1.13, right? Can you see it? Okay, now can you see the angle only go like that? That's all. There's only one answer. Because why? Can you see this one? Means the first quadrant. Now Emax is much simpler. It's always first, second quadrant only. Understand what I'm talking about, huh? It will never go how many rounds, that kind of thing. Everybody okay? Alright, okay, good. Now, then I need to remind you of something about your presentation. Everybody please listen to me. Okay, I'm going to say this one more time. When angles are in degrees, you know every time when you talk, when I look at you, you tell me you never talk. I saw you talking. And it's irritating. Try standing up here teaching and then you see people talking. When angles are in degrees, the working must be to 3 decimal place from K, right? What about the answer? 1 decimal place. Wrong, right? Agree? Because I say many times already, okay? What if when the angles are in radians? The working will be what? Find cylindrical figure from K. We follow the normal one. And what about the answer? 3 cylindrical figure 1 order. This is we follow the rule. Do you understand here? Yes or no? Okay, now, are we clear? Now, I think in Amex, I already told you, you only change the mode when you want to take sine, cosine, tangent. Okay, otherwise the 2 modes are when you do your arithmetic, it's the same. Even you also want to go to the right? So on. Okay, now can we look at example 9? I have example 9 and example 10 only. Okay, I'll look at the board now. Okay, let's all look at example 9. Okay, this is the question. In triangle ABC, is 0.72 radians. Calculate the length of AB. Now can you see, this is actually torcaso, but it is in radians form and not in degrees form. Can everybody understand what I'm talking about? Okay. First question, they want you to find the length of AB. Can you look at AB? All of you look at AB. Can you tell me, is it torca also? Torca also. Tangent line. So, tangent 0.72 will be 8.4 over 80 line. Correct? Now, this is the dark here. Do you want to put degrees here? Do you want to put degrees here? No. When you need to put degrees, you put degrees. When you don't need to put degrees, don't go and put degrees. Understand? Okay, so AB will be 8.4 over tangent 0.72. This one must change to radian mode. Okay, all of you key in. Give me to find from tape. Give me to find from tape. 5 point. What's the answer? 9 ah? 9 point. 5. 8. Can you one number give me? 9.1. 5, 7. 7. 1, 2, 3, 4 more. 3. Is it 9.5773? Okay. One answer must be 368. So 9.58 cm. Is that clear? Okay. Function you also going to stand at the back. You going to stand at the back. Now. Yes. I don't care whether you sleep. I saw you talking for many times. I'm not blind. Go. Anybody who misbehaves in my class will have the same treatment. I don't care who you are. Pass max or fail max, all the same. It's the behavior that I'm not happy with. Clear? Next question. Find AC. Okay. All of you look at AC. Now, we know this is 9.5773, right? I already told you many times, right? We try not to use the info that you found in case it's wrong, right? So, let's say I don't want to use this. How can I find AC? Huh? Oh, sine rule. Torcaso sine, right? Sine rule is different from torcaso sine, no? Okay? Sine ratio. So, sine 0.72 is 8.4 over AC, right? Okay, key for me. 5 truncate. What's this answer? 12.739. Okay, so this is 12.7 cm. Can you see? Yes or no? Now, if let's say you want to use Pythagoras theorem, is it okay? Yes. But when you use Pythagoras theorem, you must use this one. You cannot use this one. Do you understand? This is a very, very serious mistake. Do you understand? Do not use the rounded off one. Everybody clear? Cannot. Now, I want you to see my presentation. Can you see that I didn't write degrees here? Because they are all in radians. And there's no need to write radians. It's understood that it's in radians if you don't write degrees. Everybody clear? Okay, huh? Alright. Now, next one, example 10. Next question. Can you look at example 10? I give you 1 minute. You read through the question first. some things that you need to know as a math student. If you don't even know this as a math student, what's worse, you are a math student, that's really shame on you. I say STEM. Okay. In triangle PAC, PA is 9.4 cm, PC is 14.2 cm, and angle PAC is pi over 2 radians. B lies on AC such that angle PBA is 1.1 radians. Calculate ACP in radians. Where's ACP? ACP, here, right? I want to calculate this in radians. Now, if I want to calculate this in radians, can you see I must look at the big triangle? Can all of you see I must look at the big triangle? Okay? Use what? Broadcast, so, which one? Huh? So, that means I use sine, right? So, sine angle PCB will be 9.4 over 14.2. So, angle PCB, sorry, they say ACP, it's the same, ACP. ACP. Can you give it to me in 5 truncate first? All of you key in. This is in radians. Give it to me to 5 truncate first. You cannot give me the answer like my normal tech students can give me, then something's wrong with you. What's the answer? 0.7, 2, next number, 3, 4, 4, 1, 2, 3, 4, 5, right? So final answer is what? 0.723. You don't have to put radians, you know it's in radians. Understand? But what if you want to put radians? Also can. Understand? Then no need to spell out, just spell out RAD. Understand what I'm talking about? Okay? Now, next one. The length of AB, and all of you look up. How do I find the length of AB? I look at the small triangle, I use tangent, can you see? Okay, so tangent 1.1 is 9.4 over AB. So AB is 9.4 over tangent 1.1. Give me to find from K now. I say now. K. Okay, 4.3. So the final answer is 4.78 cm. Is this okay? 4.78 cm. Are we alright? Last part, part 3. Find the length of BC. I want to find this length. BC. Now I think it's quite simple. You already know AB, right? Right. You can use Pythagoras theorem, find AC, right? Okay? Now let's work this out. AC squared plus 9.4 squared is 14.2 squared, right? So AC is square root 14.2 minus 9.4 squared. Give me the 5 from 8 now. I call the name, you must give me the answer. What's your answer? 5 from 8, go in. No answer. Aaron? Take 5, 6, 4, 3. Is this correct? Is this 10.643? Yes or no? Now, if AC is 10.643, how would you find BC? 10.643 minus 1. 4.7843, right? Okay, minus for me now. I want the answer on the calculator first. Okay? Oh, I forgot to spell it. Okay, okay. So what's this answer? Now, then there are two things that I need to remind you, okay, and these are important, okay. Now, these two, I will go through again on Monday. Is that understood? Okay? Alright, now, I need to revise these two with you so that you will know what we are talking about. Now, if I have a triangle, A plus B plus C must be 180 degrees, right? Angle sum of triangles, right? This is when it is in degrees, correct? What if it's in radians? A plus B plus C plus what? Pi. Can you see this is in degrees, this is in radians? You cannot tell me I don't know. You don't know, then get out of the class. Understand? I say step. Okay, now. Angle A plus angle B is 360 degrees. Angles at Y, right? Correct? Now, what if it's in radian? What is that? 2 pi. You must know this, you know. You cannot tell me you don't know, you know. Okay. Then the most important thing in this part is 90 degrees. What I said in radians? Pi over 2. This one you must know. Because if it is not pi over 2, you can never use Pythagoras theorem and also. Everybody clear with what I'm talking about? Okay. Now, I'm going to give you the homework for exercise 8C. Now, this one don't need to do on full scale. Because this one is very simple. It's just from degree to radians only. Okay? I'm going to work on the board now. Seven, 8, and 9. In the notebook. Okay, let's stop the video. I want you to start.